Hello friends, today let's solve base time to buy and sell stocks problem. We have 6 problems on LeetCode. Today let's solve them all. Generally, the questions will give you an integer array and it represents the price on each day with different constraints such as how many transactions you can make, like infinity, or 1, or at most 2, or at most k. We have 4 questions. Other 2 has different constraints, such as we must have 1 day as a cooldown after we sell one stock. And the other is a transaction fee. If we sell one stock, we should pay the transaction fee. All of these questions ask us cannot hold 2 shares at the same time. That means if we buy a share, we must sell it before we buy another share. So that's you should understand. And the transaction fee actually means one sale is a transaction, buy is not a transaction. Okay. Now let's see the different questions. The first is we can only make one transaction, and we must maximize our profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit. So how do you think about this question? Generally, we should know there is a minimum number before today. For example, if we want to sell the stock today, then we must know the minimum price before today. So here, just how we solve this question. We maintain a minimum, a global minimum represents the minimum price, so on. And we assume today we sell shares. So the profit should be today's price minus the global minimum. So in that case, we have a profit. So we, at the same time, maintain a global maximum profit. Then that's the result. Okay, we just write it because I think this did not require any algorithm. It's just simple. So we first get n equal to prices.length. If n equal to 0, we just return 0. Actually, I would like to copy-paste this line for each question, because every question we should do such check. So I just copy-paste. Okay, return back to this question. We need a minimum, and we first assume it's the price is 0, and we also need a result, which is the profit. So at the beginning it's 0. Then we iterate or the other prices. So we know the result will be maximum result and prices I minus minimum, right? Minus. And then we update this minimum. Do not mix this order up. We should first get the result and then update the minimum price. After that, return result. Okay, so that's for the first question. Let's see the second question. Second question is we can make at most as many number of transactions as we like. We don't have the constraint that we can only make one transaction. So how to do that? Let's see. At each day we have 2 possibilities. That is, we hold a share or we don't have a share. So based on these 2 possibilities, we can get what to the state prior today. For example, if today we have a share, if today we don't have a share, the possible state of yesterday that yesterday we don't have a share either, or yesterday we have and today we sell it. The same, if today we have a share, the possibility of yesterday we also have a share, or yesterday we don't have, but we buy a share today. So we have these possibilities, and we can use arrays to represent. For each day, we have 2 possibilities. So now we have n days, so we have actually n times 2 possibilities. We use a dp n2 to represent each possibilities. So let's write this code. We use this dp new int n2 to represent the states. So what is the initialization? Initialization is at dp0, 0, because we want to use dpi0 represents no share. Okay, no share. And dpi1 represents with share. We have share. So the only case we should care about is that if for the first day we have share, that means we buy a stock today. So we should minus this day's price. Otherwise, we just use the transition function to update different states. So that's 0. Okay, if a possibility that yesterday we don't have a share either, or yesterday we have one and today we sell it, so we will make profit today. So we plus today's price. Okay, if today we have a share, then the possibility that yesterday we also have, or yesterday we don't have, and we buy a share today, so we should minus today's prices. And in the end, we should return n minus 1 and without share. Without share is 0. Okay, so that's it. But if we look carefully, for each state, we only need its price date. So we don't actually need this array. We can just use 2 variables. Okay, just call it no share. If no share, 0. If with share, then the initialization should just be the price is 0. Okay, we just update this just like this dp array. So if it's today is no share, then yesterday no share, or yesterday with share, and today we sell it, so we profit price is I, or yesterday today with share, and yesterday with share, and no share yesterday, and we buy a share today, so we minus price is I, and in the end, of course, the max profit should exist when we have no share, right? No share. Okay. Okay, that's for this question. How about we have transition fee? Actually, the same as this question. We just need to pay the fee when we sell it. So let's write it. Oh, okay. I just need to copy paste. Something between. Okay, just need to add when we sell it. So when we when we sell it, so here we minus the fee. Okay, so that's it. Okay, now we have 3 questions left. This we have at most 2 transactions. So from prior 2 questions, we saw we can only use we only need 2 variables to mark the state. So if we have at most 2 transactions, how many states we have? Actually 5. If we haven't involved in any transactions, we are state 0. But at that state, we don't have any profit, so we don't need this state. If we involve at least 1 transaction, we have 4 states. We have the first share, we sell the first share. We have the second share, we sell the second share. So 4 states. We use 4 variables. Buy 1, sell 1, buy 2, sell 2. So we just update every state just like prior 2 questions. So now just let us write this algorithm. We need to buy one. So the same, buy one, that means we should cost some money today, spend some money. And the sell one should be 0. And the buy two will be, actually we can initialize to negative price is 0, although it will never get this result because we should finish one transaction. So 0. Okay, then I equal to 1, I less than n, I plus plus. So we should update each state. It will be buy 1 and negative price is I. We buy the first share today. Sell 1 will be the same. If yesterday the same state, or yesterday we have 1 share. Today we sell it, so we earn some money. So we plus. Buy 2 will equal to max. So there will be buy 2 and sell 1, right? Buy. So we cost money. Price is I. Sell 2 will equal to max will equal to sell 2, then buy 2 plus price is I. So in the end, as we can make at most 2 transactions, so we should return maximum sell 1, sell 2. Do we have some cases that we don't need 1 transaction? I think this one, right? We buy on day 1 and sell day 5. But anyway, at most, so we just choose the maximum from this sell 1, sell 2. I think that should be fine. Okay, we have 2 questions left. This is a cooldown. I think you can think by yourself. How many states we can be? We can be in on a single day. 3, right? One state is that we have a share, or we are among this cooldown stage, or we don't have a share because we sell it today. So we just update accordingly. So if we have share, then previous day we can be the same with share, or previous days cool down because there must be some cooldown so that we can buy a new share. So cooldown minus today's price. Or if today we are at cooldown, then we have 2 possibilities. Yesterday it also cooled down, or yesterday we sell a share. So there will be no share state. So if another possibility is that we are currently have no share, then 2 probabilities for yesterday. Yesterday we don't have share either, so no share. Or yesterday we have share and today we sell it. So that's the transition here. So we just write down cool down. So with share the same as previous question. We just negative or minus price is 0, and the cool down 0. No share 0. Then iterate I equal to 1, I less than n, I plus plus. So what should we do? If today is no share, then no share. Or maybe we write with share first because it seems simple. With share. Then yesterday must be cool down, so we buy a share today. Cool down. Max cool down. Or yesterday is no share. Because in that case today we must be cool down. No share. Yesterday no shares. So yesterday no share, or yesterday with share, and today we sell it. So we plus price is I. Okay, so in the end we should return no share. That should be the largest profit. Okay. Okay, now let's see the very last question. very last question is, we can make at most k transactions. Let's recall for the previous questions, we only need variables, 2, right? In that question, we can make at most 2 transactions, we need 4 variables. So if we can make at most k transactions, we actually should need 2 times k variables. So in that case, we can use 2 array. Each array has k, length of k, right? Then I think mostly are the same. One tricky part is the initialization. Because we want to get the maximum profit, so we should initialize all these arrays to a very small number. So we should integer the minimum value over 2, but by 0. That means we buy the first share, so we should be negative price is 0. How about 0, 0? That should be 0. Okay, that's the initialization. How about the transition function? Transition function is that we iterate I from 1 to n, just like previous questions. And within each I, we need to update the by j. J start from 1 to k. The same as the previous questions, we update by j and equal to max by j or sale j minus prices I. You may wonder why it's still sale j, not by j, because owning sale is treated as a transaction. So if you just buy it, it's not a new transaction. So you can just use the sale j. But if you update sale j, then this part should be by j minus 1 plus prices I. Because, as I said, sale is a new transaction. So you can only use the last transactions by. So that's the difference. Okay, let's write the code so you may understand this part well. So we need 2 variables. We call it by the new int k plus 1, or sale new int k plus 1. Arrays fill by to integer minimum value over 2, or arrays fill sale integer minimum value over 2. And we know by 0 should always be negative prices 0, and sale 0 will be 0. Okay, then int I equal to 1, I less than n, I plus plus. We should, it's like initialization every time. By 0 should be max by 0. And the sale 0 actually is prices I. Yeah. Okay. So if we make the first buy, then it should be the maximum among the by 0 and negative prices I. And then j equal to 1 j, j less or equal than k, j plus plus. What should we do here? By j equal to maximum by j, and sale j, we buy, so we minus prices j, or we sale j and max sale j, and they should be last buy, so j minus 1 plus prices j. In the end, because at most k, so we don't know how many transactions we make. So in that case, we should just get the largest number, j plus plus. So we let the result equal to 0, then update the result equal to max result to sale j, and in the end return result. Okay, So just this tricky part, j minus 1. And okay, we have some mistakes. Let me check. Buy, yeah, sell 0. Correct. Buy 0, maximum buy 0, sell 0, minus price is I. And buy j equal to maximum buy j or sale, so we buy it, so we minus. And sale j mass sale j and buy j minus 1 plus j equal to 1, j less or equal than, oh sorry, I know the problem. We did not update the k. Oh, I think it should not be the problem. The k should at most be, minimum should be minimum, k or n over 2. But I think it should not be this problem. Okay. Let me check what's going on. Buy negative price is 0, sale will be 0. Correct. So here, buy 0 will be maximum buy 0, sell 0 minus price is I. J by j, maximum by j, sell j, buy, so we price it. Oh, sorry, this should be I. J is just J is about which transaction are we, but for the prices we use this I. So do not make this mistake. It's very very tricky. I almost make the same mistake. Okay, thank you for watching. See you next time.